from every skier I have met, they put all disposable income and more than they have disposable into their skis.
That's good for me.
It's good for your business.
Good for me.
Well, this
Hopefully,
is how,
you know, we'll find a few more of those, you know, these techies here. You know what would be great? We should make a Michigan Tech College of Engineering ski. We should have the graphic on it. There you go. And you can hang it up in the office, hang it up there and say, look at this, built by alum.
Or just a nice image of a Husky.
Absolutely.
Notice how I have a beautiful, you know, model of a Husky. So,
like this one.
Yeah, I mean, just a nice image of a Husky, because then it's a story, right? People,
Absolutely.
That's right. That's right.
And for those of you watching, I will show some images of these particular. These are 3D printed, off of our brand new 3D metal printer. That costs a ton, and the big one is aluminum, silicon, 10 magnesium.
Oh, sure.
I don't know. Is that called something, Iver?
That's how everybody refers to it. We've got a lot better one than that for you, Janet.
Oh yeah.
Yeah. Oh yeah. Yeah.
Like a 3D printed one?
No. I'm just saying a lot better powder than that one.
Oh.
We've got an alloy that will blow that one away.
Okay. Well, that's good to know. And so there's going to be this Days of Giving, and I'll talk about it in a minute in the slides, but this is going to be one of the kind of random drawings. And this one's hollow, and the first model was solid, and this one is actually lighter than the solid one, or about the same weight. Yeah.
Wow.
Very cool.
I thought you were going to say that the interior cavities of the bigger one were made lifelike or something like that.
that would be an interesting 3D printer. Well, who knows? You know, I don't think we'll ever get to that, but we might. Oh, yeah. No, it is bitter cold outside. It was 0 on my ride home, and we got somewhere at my house. We got over a foot of snow. Easily. We had 8 inches by morning. It was over the tops of my boots. And
Wow.
I know Greg always tells me I should get higher boots, but I'm like, no, it's good enough, you know.
That'll be a couple more years in the copper country, and then you'll switch over.
Yeah, I'll switch.
Yep. Yeah, that'll get a pair of cross-country gaiters.
So we have a couple of notes. Hello, Piersmas. Guten Abend. And Kent says there's no snow here in Atlanta. Which is not surprising to me. When there is snow in Atlanta, it is the most amusing thing to watch outside your windows from safely in the house, to see the cars slithering down the street, you know. I remember once, out of my view, because I lived in Decatur, and it was a hill that kind of just rolled down to a stop sign at the bottom. There was a garbage truck going sideways down the road.
Wow. That's a big vehicle.
It was slowly descending. And, you know, the poor driver had no idea how to get out of a skid like that. He didn't know. It never happened before.
So my middle daughter lived in Raleigh, North Carolina for a while. And she complained because, one time they had, you know, like 2 feet of snow, a big dump. And she's the only one that knew how to drive on that highway. And she was driving a stick. And she was driving an old Subaru that I gave her. And she was just fine, but she was worried sick about the people that were coming up behind her and stuff. Ooh.
It doesn't matter if you know how to drive if you're down south. What matters is that nobody else does. You know, you just stay off the road.
That's right. Oh man.
Yeah. All right. Well, I'm going to share screen and
all right.
start to get started. There we go. Can you see my Husky Bites starter slide?
Oh yeah.
Yes, Kim.
Okay.
I always like that one.
Start from the beginning. Yeah, no, this is a beautiful image we actually purchased, and I mean, and clearly no Husky ever posed for this, because no Husky would ever pose for a picture like this. They would never let you put a shirt on
Mine
them.
wouldn't.
No way. They would. So welcome everybody to Husky Bites, January 2023. My name is Janet Callahan. I am Dean of the College of Engineering, and it's my pleasure to greet two speakers tonight. Just a few things to announce: that all webinars are posted shortly after the event, and so you can kind of look through a whole library of a whole bunch of different segments. These are all focused on Michigan Tech or on the area around Michigan Tech, or generally have something to do with Michigan Tech, featuring alumni, for example. But it's also an opportunity to learn something new. We have lots of different audiences who join us. And just a quick poll, because this is the second one of the season, to see who's joining us today. And so if you're joining us for the first time, you can enter who you are. So if you're a student, if you're a pre-college student, if you went to Michigan Tech, if you're a faculty or staff or a friend of Michigan Tech, or family of current or future students, or just a curious person. And so you can probably see this. I know I can see it right in front of my screen here. Approximately 80% or so went to Michigan Tech at some point or another, including both of our guests tonight. And then we have kind of a little bit of people from a bunch of different categories, including 8% curious people. So thank you for joining us. And I'm going to close that out and move to the next slide. Okay, so tonight we are going to be learning about making skis, and we'll hear quite a lot more about that in a moment. But I just want to point out that Shaggy's Copper Country skis are a real thing, named after Jeff Thompson's great uncle or something like that, if I remember that right. Yes, great uncle Shaggy, and also the area up here, Copper Country. And then coming up next, we're going to be seeing some statues being built live with some geospatial images focused by Joe Foster and the Douglas Houghton NSPS student chapter, which is the Society for Professional Surveying, if I have that right. All right, so this is a second alert, the fact that we're going to have a Days of Giving challenge, and I'm really excited about it. It's going to take place starting Wednesday, 4 p.m. of Winter Carnival, and it will end 24 hours later. So if you want to learn a little bit more, just go to giveback.mtu.edu. And in the meantime, I just wanted to tell you that each department will have various challenges, so you can give to your home department. But if you want to kind of give to a more general category, or kind of at the college level, we're going to be focusing on several things. First of all, Prep for Tech, which is a math boot camp, a voluntary math boot camp, not a prison, which we started the first, I guess it was fall of 2020. The week before classes started, because as leaders, we were wondering what were the effects of ending up in lockdown was going to be on our entering students' math readiness. And so we had a big donor who gave enough money to support it for a couple years, and we made it available at a nominal price for students to elect to join. And we had 10% of our entering class come to Tech a week early to study math. And so we did it again last year, and we'll be doing it again this year. So if you'd like to give in support of that, we've had a generous match from Ralph Larson, class of 81. And the second one I wanted to mention is that in general, STEM outreach is really important. You know, I know that my choices for choosing engineering were influenced by some of the opportunities I was able to have. And so to that end, I just wanted to say that there is an opportunity to be entered into a drawing for a unique homegrown 3D printed metal Husky. And then we'll also be collecting, or if people want to give to the Society of Women Engineers in support of scholarships, that will also be available. And then finally, the first 100 people who donate $100 or more during the Days of Giving will receive a t-shirt. All right, and I have some of these to show you in a moment. So these 3D printed Huskies, I want to show you what they are. And so the tall one is made out of aluminum, silicon, 10 magnesium, 3D printed. And we have them with and without it saying College of Engineering. The other side says Michigan Tech. And the smaller one, I think, is a stainless steel. And I know I should know, being a metallurgist, but I just wanted, so this is taken today on the windowsill outside my window by Danielle Davis. And again, up next, we already described this. With that, I want to just remind people that you can ask questions as we go along by typing in the Q&A. And you can also just say hello to somebody you know by writing a comment in the Q&A. The chat, like the out loud discussion feature, is not available, but I do encourage you to ask questions, type them in as you go along. And I wanted to show you, so that this is the t-shirt. It will say MTU Engineering, black all over. Well, I think there is something on the side that says, oh, on the back, of course, this. So it's a nice t-shirt. And then again, these are the beautiful 3D printed Huskies. All right, now having said all that, Jeff, why don't you share screen and let's get those slides up while I introduce you both. So first, I'd like to introduce Iver Anderson, who's officially tonight's co-host. Iver is a Michigan Tech alum. He earned his Bachelor of Science in Metallurgical Engineering, and then he later went on to earn his doctoral degrees somewhere else. He worked for a while at the U.S. Naval Research Labs and then took up a post at Ames in 1987. Iver has a really lasting legacy on this planet, not only for being a grandpa, but for also helping to invent, or inventing personally, I haven't heard the story yet, Iver, lead-free solder while at Ames lab. He is in Inventors Halls of Fame and has saved the environment from just a ridiculous amount of lead ending up in the system. So thank you for that invention. He's a lifelong skier. He grew up in Hancock, which is just over the waterway. And he's on our advisory board. And so for all these reasons, thank you, Iver, for being a co-host. And then with that, I want to introduce Jeff, who is also an alum, and you are mechanical. Is that right?
That's correct. Yeah.
I thought so. It's class of 12. Jeff started building skis as a hobby in about 2005, and 3 years later, he was selling them. And I think his brother was involved in this, and his father and his great uncle Shaggy, and I think he's going to tell a little bit of that tale. He is from South Lyon and now lives in Petoskey. He's from a family of makers, including and has grandparents from up here in the Keweenaw. He married an alum as well, a chemical engineering alum, and is a dad, and also an avid lifelong skier and just passionate about his craft. And so I'm really looking forward to hearing you talk about your materials tonight, Jeff. And I'm going to turn it over to you, Iver, to handle it from here.
Absolutely. Thank you, Janet. Yes, it's great to be on, and really appreciate this chance to talk about one of my favorite subjects too, and skiing. And actually, because I am a metallurgist and a material scientist, I should say, the materials that go into a ski are incredibly interesting to me. And the whole idea of using skis as experimental composites, especially actually, there's a linkage between ski making and the materials that go into skis, and also things like helicopter blades, actually. And I think when Jeff and I are talking about this, we'll all clue you in on some of those linkages and how skis have evolved actually over the years. I brought an old pair of my skis, and we're going to compare skis as we go along here too. So really neat to meet Jeff and to find out what it's like to make something that you enjoy using so much. So I'm looking forward to Jeff's presentation here. And we will kind of split the time as we go along, more as a conversation, actually, through the time period here that we have. And a lot of the time we do want to spend talking with you. So questions that you have, please put them in the chat, or I think we have the ability to do live voice. Is that right, Janet?
Not for the Q&A, they will be typed. So they
Okay.
type them in the Q&A, and then we choose to answer as many as we can.
Okay, absolutely. So let me turn it over here to Jeff, and you can run the slides, Jeff, and we'll conduct this jointly. How about that?
Perfect. Look forward to it. Yeah. Well, thanks again, Janet, for including me in this. It's definitely been a passion and something that I basically tried to tailor my mechanical engineering degree to making skis, because like you said, I started making skis in 2005 before I came up to Michigan Tech. So just wanted to basically go over a little bit of how we make skis, some of the materials that we put in them, how we got started, and like Iver said, go over anything anyone's wondering about. It's a pretty cool sport because we can have everyone from, a 2-year-old to a 102-year-old out on the slopes. And clearly that's, if you've been around Michigan Tech, you're ingrained in snow, and we can be a little bit of that experience for you. So I want to kind of pull up. I think it's great to get a little bit of background because this shows you're skiing some pretty cool terrain.
Yes, this was looking down. They had the snow had just come a day before. We were skiing on 2.5 feet of fresh snow. I was skiing with one of my students here, and we had a crew of about 4 of us that were enjoying Mammoth Mountain. Had never skied there before. It's right on the border, basically, of California and Nevada, and it's got some good steeps. And just below, if I'm standing on the cornice there on the left, and just down below me is a pretty good drop into a lot of deep snow. So it was tempting right there.
Well, that's what we got to make skis for. So
Exactly.
yeah. Quick slide here. Skiing at Mount Bohemia in the Keweenaw Peninsula always has a good deep place in my heart. So just a quick history of Shaggy's. Here on the right, you can actually see my great granduncle Shaggy, Sulo Shaggy Leto, who used to carve skis for our family and friends and neighbors in Kearsarge, so just past Calumet, up there in the Keweenaw. And in 2005, my brother and I, Jonathan, started building skis in my parents' barn. It was literally like a kitchen table thing. We'd try to draw out skis in a basic CAD program, draw out the top view, the shape of the skis, and literally paste together 8.5 by 11 sheets to try to get a full size, try to make a template of something, and make skis. And pretty soon after that, we kind of were cleaning out my grandmother's barn after she had passed, and we found some skis. And my dad told us, these are skis that your Uncle Shaggy made. We're like, what? We had no idea who Uncle Shaggy was. So it was my grandmother's uncle, and we heard stories of how he used to carve skis for everyone, and we knew like right away Shaggy's Copper Country skis. Now we just say Shaggy skis. It was fate. It was 100 years later. So basically, when we can have heritage like that, you can't pass up on it. So in 2008, 3 years after we started making skis for ourselves, my brother, my father, and I, all kind of in different locations. I was at Michigan Tech, my brother in Colorado, and my dad down in South Lyon formed our business, SCC Skis, Shaggy's Copper Country Skis. We started selling to our friends, and we're working out of my dad's wood shop. He had a wood shop in his barn. So my brother and I we cut apart steel from an old building to make our first ski press. And, it was basically trying to find any way. We didn't really know how to make skis, but we were figuring it out in 2005. And in 2011, we moved out of that pole, out of that barn, and into our first commercial space. So it's a little history about Shaggy's. This is a little bit more interesting, a little bit more of the meat and potatoes of skis. So I'll kind of go through this, Iver, and then you can hop in. So basically, the way that we make skis, they're built in a sandwich style, meaning that we're stacking up different layers of material on top of each other, and we are putting epoxy between all the different layers. So basically, you can think of how a ski is made. You have the plastic ski base material with an edge on it, and then you have a composite layer that's going to reinforce the ski. You have a core material, which we use hardwood, and a sidewall that protects that from any water. You have another composite layer on top of that, and then a protective top plastic top sheet. And that's basically, in its simplest form, this is what the inside of a ski looks like. This is about half of a ski that you can see here. But ski construction has been like that for quite a while. But if you want to jump in here, Iver, on
Sure. This is this is how the evolution of skis has come over the years. And I know that I've got a pair of head giant slaloms here in my office that I brought over, and I think when we get to the dimensional slide here, then I know Jeff and I are going to compare dimensions on skis, old skis and new skis. And what's neat about this kind of composite here is that there has been this laminated, we would call this a laminated composite, with laminates of fiberglass and the core material being hardwood. This is probably one of the first general kinds of composites that were developed. The ones, this giant slalom that I have actually has some aluminum sheets in that layering as well to give it a little bit more strength, because actually my skis are tremendously longer than these. And there's a couple of issues that are important for the strength of the ski. And one of them is actually the ability to twist the ski, and that's called torque. And the other is really the ability to bend the ski. And the bending of the ski is how you absorb a lot of the terrain variations. But the twist, the torque resistance is how you hold on ice, especially. That's two characteristics here. And the construction of the ski really allows you to design that into the ski. And so, I think it's really neat that, Jeff and his brother were basically looking at existing skis and then figuring out, what kind of variations in the composite that they can do to change its behavior. So I think that's just a little bit on the material side there, I think, Jeff.
Yeah, absolutely. And you're right. Resisting torsion is absolutely huge when we're talking about skiing on icy terrain, and that longitudinal bending down the length of the ski, which I guess we can dive into on a couple of slides in here. But that defines so much of how the ski is going to work. So it's a really important part to bring up. Yeah. So when we're talking about the composites in the ski, we're wrapping around a core. In our case, historically, skis for a long time have had wood cores. Then there was a number of years where cores were made out of different foams, honeycomb materials, both aluminum honeycomb and aramid honeycomb. And over time, the ski industry has always come back to using hardwood in the skis. And the tooling is actually, it makes it simpler to produce a ski rather than injecting a foam or working with honeycomb going into the core. But it's a biomass, so it's a little bit more difficult to work with. I don't know if I should say difficult, but it's more interesting to work with. Any woodworker will tell you that wood grain isn't always perfectly straight, and it presents its own set of challenges. But the 3 different types of wood that we use in skis are ash, we use white ash, tulip poplar, and aspen. And we really revere the use of ash. It's extremely strong and snappy in its overall flex, and like the feel that you have in a ski when that ski, you load it up into a turn and you get the rebound of that wood. You can actually, even though the composites are handling a lot of the stress of that ski bending, the core actually does have more effect than sometimes you'd think. If you skied them back to back, you can actually feel it. Even a pretty recreational skier can feel the difference between species of woods. So we have that. The downside of ash is it's very dense. Its density is roughly twice that of tulip poplar or aspen, and that means the ski is going to be heavier. So especially when we have a wider ski, an all mountain ski, and you have quite a bit of core material in it, it's important for us to try to reduce weight where we can, and not be detrimental to the overall design of the ski and how it's going to be used. So we blend that a lot of times with the poplar. So essentially you'll have 2 stringers of ash running down the center of the ski, 1 narrower strip of poplar in between, and then poplar going to the outside. And that really helps with reducing the weight in the ski while still maintaining the longevity and the snappiness of the ash in the ski.
I think one thing you mentioned a couple of details here, and just let me talk about the hexagonal honeycomb kind of core material, either aluminum or aramid. It's kind of like an epoxy paper, you could say.
Mm-hmm.
And for a long time, I actually had some Hart honeycomb skis that were made with aramid honeycomb, and they are extremely light. And that was a nice thing, especially for throwing them back and forth into bumps. But they also did not have that recovering capability as the wood does. And eventually I broke them. But and that was, I think, the really why they didn't last. And you could say too that helicopter blades actually right now are made out of honeycomb. Most of them are aluminum honeycomb instead of the aramid fiber. But that's why the aluminum honeycomb is used for helicopter blades just to resist that torque. Same kind of thing that we're talking about here for skis. So a nice crossover actually between, sort of what's an aeronautical material and what's
right
and what's a ski.
Absolutely. I figure I'll just answer this question. Steven says, how difficult is it finding ash with the emerald ash borer? And that is one of those things that it is a little bit more challenging. And basically, we have to make sure that the wood is it's harvested before it rots. So the emerald ash borer will go through, kill the trees everywhere, and the mills that we get our wood from, or the loggers that they get their wood from, are very active in going through where the emerald ash borer is going through. So they'll go through dead areas, harvest the trees, and the heartwood is still able to be used. So we can get that. So essentially they're traveling all over Michigan and chasing it through different areas, but we do have kind of a contingency plan going to a different species of wood in the future if we ever get to that point. There are warehouses that are stockpiling it right now, though.
And the ash borer only goes after that zone between the inside of the bark and the outside of the tree there. So
right.
Yeah, you can avoid it.
Yeah. So we'll go ahead and hop into basic ski components. This is kind of
yeah
cool stuff. Essentially, what we saw on that cross-sectional view of the skis, but these are actual components. So you could see the blue and black and a Shaggy's letters, the bottom side. That is a ski-based material. And that is, a lot of people know it as P-Tex. And that is, P-Tex is a name brand for a company in Germany. We get ours from the one supplier in the US, Crown Plastics, and they call it Durasurf. It's an ultra high molecular weight polyethylene that is sintered rather than just extruded. So is very abrasion to resistant. It will hold wax very well. And we use it's called the 4000 grade. So it's a longer molecule chains, and that's generally regarded as like a race grade, and it's more resistant to abrasion than other skis or than other base materials. And it's very important because when you think about it, snow, ice crystals are very hard on different equipment. The abuse that skis go through is tremendous, and that's what you're essentially what protects everything and your running surface. So we'll have that, and jump in anywhere, Iver, here. The composites that go above the core. So we have fiberglass, carbon fiber. We also have additives like a magnesium insert that goes into our skis. We'll have a shout out to Nanomag LLC and Bob Carnahan, who developed this. We worked with CPM Enterprise to try to figure out a use for this magnesium in the skis. And magnesium has a unique ability to dissipate mechanical energy as heat. So essentially, we use that to remove vibration and chatter in the skis. So we really reduce how much the skis are vibrating when the snow is hard. So that really helps improve your edge grip.
So for all those metallurgists out there, the mechanism, of course, is that magnesium is twinning and untwinning. And that twinning mechanism, passing that interface through the magnesium, is the dissipation of heat. And I think there are other metals that will do that too, but magnesium definitely lightest and strongest doing that.
Absolutely. So very cool. Another Michigan Tech connection there. Here you can see some of these strips. These are called rubber bonding strips, or so there's some here and some strips down here. And whenever we have very dissimilar materials that are, or very stiff materials, like imagine you just go and try to glue two pieces of steel together with epoxy, which is a pretty stiff adhesive, and you go to bend it. Well, typically what would happen if you bend it quite a bit, the glue line, the bond line, is going to break. So what we do is, on top of the metal edges that are on the ski base, we'll put a layer of epoxy down, and then we'll put a strip of rubber over top of that to reduce the shear stresses between that and the next layer, which is fiberglass or carbon fiber, depending on the ski. So we have that, and that greatly improves the longevity of your skis, and those bonds don't break down nearly as quick as they would without that. So we have that. Plastic tip and tail bumpers to protect the ends of your skis. So when you're skiing at Mount Bohemia or out in at Crested Butte or Big Sky, when you smash your skis into a tree or a rock wall, you don't get to that wood core that's going to, break down with water. We have to keep everything sealed up really well. So good accidents just happen when you're skiing. So you gotta protect it and plan for it. All righty. Anything else you want to add on this slide, Iver?
That sounds good. I know that rubber compliant layer between the like stiff materials is extremely important. And you were talking about all the vibrations also that these skis are subject to, and that compliant rubber is definitely helping the epoxy, which is very stiff, to continue to hold as well as it does.
Absolutely. Yeah, it's absolutely critical. I mean, skis, there was issues in skis, 50 years ago, where skis edges would just come out. They couldn't figure out how to bond them, and having the compliant layer in there solve the equation. I was told by an engineer from a much larger ski company many years ago, said, when we have issues, we add rubber. And that was the best piece of advice that I think I've probably ever had in the world of making skis.
You know, Jeff, I did want to ask you, I guess, and might be useful for everybody here, is when you were first looking at how a ski is constructed, what did you use as your model? You must have tried to do what we would call reverse engineering. Is that right?
Yeah, yes, reverse engineering. When I was in high school, I actually I'll make this quick. I was putting skis on my bike for after a ski race, and my dad gave me some old straight skis that were not being used, and I cut the tips off of them, and I looked at that cross section just right at the cut, and I looked at it and I said, there's wood, fiberglass, plastic. This doesn't look that complicated. I think we can make this. The year before I'd made a surfboard, so I started like working with fiberglass and epoxy. Yep. Well, 18 years later, it's gotten a lot more complicated again, but but that started it all. It was just looking at the cross section of a ski, not knowing anything about what composite weights should be used, what kind of, how a core profile should be developed. And we'll say a lot of empirical data later. It's pretty refined.
Wow. That's great. Yeah. I mean, all my experience was always on soapbox derby cars. So that they were not as sophisticated as the cross section of a ski though.
Yeah. So on here, on the reinforcement of the skis, basically the composites, when we're looking at, and like typically in a composite panel, a lot of times the core is looked at as just becoming a gap between the two top layers, and how can you make that as light as possible because you have no bending stress in the middle of an I-beam. Well, when you start looking at it, that same concept kind of applies for skis, although the core is a much larger portion. But what we're doing is, like on this top layer of an I-beam, the flange, that would be our top composites, the bottom are your lower composites, and your web is the core, wood core of the ski. So that's really what we're using, that concept to make the ski not a solid composite and super heavy. So we do that. But kind of more important about this slide here is talking about the multi-axial reinforcement, where, like Iver was talking about before, we need to be able to withstand stresses going down the length of the ski, and that ski's bending, and that ski has to bend to initiate the side cut, like the arc of the ski. That all has to work together. And then you also have reinforcements going at plus and minus 45 degrees to help resist torsion in your ski, to give yourself edge grip on ice and hard snow. And it's kind of counterintuitive in snowboarding. A lot of times guys like to have more torsional flex, which is kind of beyond me, but that's why I'm a skier, I suppose.
Yes.
All righty. So real quick, I know we're coming up on time here. So evolution of skis. I mean, basically we have one of the pair of skis here my father's holding that my great granduncle Shaggy made, and the pair that I'm holding is a ski with no fiberglass in it. It has an aspen wood core, and that's wrapped with carbon fiber. It's extremely light, wide, it floats well, it climbs uphill very easy because it is so light. And there's a lot of history in between those two. So if you want to dive into that at all.
Sure.
I was going to say, now I see why you said carving. Your Uncle Shaggy carved skis.
Yes, hand carved.
Oh yeah, one piece. I just think it's really interesting how there's still a wax gutter down the bottom of that one, even at the very beginning. And that's what we call wax gutter. I used to race a lot, and that's the hardest thing, is to keep that slot in the middle clear of the racing wax you're trying to apply to the PTEX. and even those wooden skis, because they have an open grain also and can hold wax. People used to wax the bottoms of those skis. It was many, many years until people figured that gutter down the middle of the ski was not actually needed. And I forget when that happened, but I don't know. You may know. Maybe the last 10, 15 years.
I mean, I on the cross country side, I couldn't. I am not that knowledgeable.
Okay.
But on the downhill side, yeah, that hasn't existed for a long time.
Yes, exactly. The skis that I have in my office here definitely have a wax trough in it, and some of the other characteristics of the skis that you're holding, but definitely they show their heritage back to your great uncle's skis.
Yeah. So here we've got just a little bit about modern ski design, and modern ski design basically all revolves around this term of side cut, where the ski, the overall top view of the ski, the sides of it have a circular arc, and they are going to form imagine if that radius was turning, or if that ski continued on its radius going down the length of the hill. Say a slalom ski would have about a 13-meter radius, and it would make a circle with a radius of about 13 meters, and that's pretty quick. And that's modern skiing since the mid 90s that really started taking off, and by 2000 just about every ski started using a side cut radius from that 13 to 25 meter radius, going from Iver skis back there might be a 45-meter radius or a 50-meter radius. And they were using more of the bend of the ski to carve versus having you have your side cut, the edge of your ski just engage and start turning. And that really started modern carving. So everything's basically based around that. The width of skis now, you see a huge variety from basically 65 or 60 millimeters all the way up to 120, 130 millimeters wide for a powder ski. So a race ski is going to be on the narrower side at 65 to about 68 millimeters. An all mountain ski could be 98. This one, 97.6 in the slide here. That is the ski behind me over here. That's our Mohawk 98. And that's an all mountain ski for somebody who chases a little bit of snow, but also skis on hard pack. Not necessarily ice. If you're skiing on ice, you might want to keep it under 90 millimeters. 80, 90 are really nice front side skis. But you get a little bit wider than that 65 or 70 millimeter range, and you get a lot more versatility in mixed conditions because the ski's able to get up and over it and bust through that crud and track through it really well. So
yeah, this is so the width of the ski at the waist. That's this difference. That's what we talk about width underfoot. And real quick, I'll just measure mine right up now. Mine are right at 64. So, and these are giant slalom skis. So they had like Jeff is saying, the arc, I'm sure is very large. They're meant to make giant slalom turns. So you're talking about, a turn every, I don't know, let me just say 25 yards, something like that.
Mm-hmm.
And not real sharp across the fall line. But they're also made to be very long. And exactly as you're saying, in order to initiate the turn, you really had to press hard to recurve that ski underneath your foot. And now that's what I love about modern skis is all you really have to do is tip them from side to side. And you've got a fantastic carved turn. So
Absolutely.
I'm a convert.
That's very good. You got to, you know what? You've got to, sometimes when it's just like cheating, you get on the right equipment and it just makes it easier.
But
Oh. So go ahead.
I don't know how many more slides you have left, but feel free to pick out any questions along the way, unless we are right close to the end here.
Sure. I think there's 2 or 3 more here. Anonymous attendee about recycled materials and more sustainable. We'll actually get into that in a couple of slides here. Do you ever use a blend of wood veneers by Steven? We actually don't use any wood veneers in our skis other than we've used them as a graphic. We do all vertical lamination in our ski course rather than horizontal. So that's what we do. Nope. And Steve LeBeau from Nanomag, thank you. Got a good supply of Nanomag coming in.
Well,
Steve
go
LeBeau,
ahead,
you're kidding me. Wait,
go ahead and finish
This
up your
Steve?
slides then, so we can
Okay.
turn off the slides.
Yep.
wow, Steve LeBeau, cool. I know him very well. Glad to hear you're doing well, Steve.
So just real quick, our assembly and pressing of the skis. So once we have all of these components made and spec'd out for the right ski, we are going to do our, what we call a wet layup, where we're putting epoxy between all the different layers, stacking them on top of each other. And then, so they'll be put into what we call a cassette that's going to go into a press. It's going to form everything together. And then those are heated. And in about 37 minutes, the cycle is done. The skis are going to be fully cured up to about a 99% cure in the press. And then they'll be pulled out and they'll sit for another day before they go into finishing. So I think we can probably skip this one. Well, I guess it auto plays. Just a little bit about some of the equipment that's used in making skis. We use CNC mill, some different tangential knives that cut the material, basic woodworking equipment. Let's see. Here's some of those cassettes that I was mentioning that go into our molds, and these form everything in the ski. They hold all of our materials aligned with each other. And then here's one of our presses. They're very, very interchangeable because we do so many different skis in a week. So everything is made to swap quickly. And then through here, we have an automated grinding robot that's taking the skis and it's putting a structured finish on the bottom, and it's using a ceramic disc to polish the edges and sharpen them to a very specific degree. So they cut into the ice very effectively and they run smoothly on the snow. All right. Anything you'd want to add to that, Iver?
No, I think that's a really good illustration right there. I'm just starting to, my internet is a little weak, so I'm gonna go upstairs where I can get it better. Sorry about that, Jeff.
No problem. So our 3 poll questions here.
All right, so we're going to start with the first poll question. We're curious about the skiers out there. What is your current ski length? So you have 5 choices. The first choice is 150 to 160. Second choice is 160 to 170. Third, each one adds 10 millimeters. And the highest category is 190 centimeters plus, which is, you would need to be very tall to handle those, I would think, or really accomplished skier or something.
Yeah, not too many people are skiing on those now, but they do exist. We just made a pair of 198 centimeter skis.
Wow.
Well, and it
they were
looks like
115 millimeters wide underfoot. They were a big pair of skis.
well, it looks
Oh,
like
man.
it looks like it's a Gaussian distribution here with kind of the majority in the 160 to 180 centimeter range.
Yep. Very
So
typical.
Ivor, what would you have answered for this one?
I mean, at this point right now, I have my own personal skis are 190 plus. 200, 205s. But at this point, I love the modern skis, so I'll rent them. And when I rent, I usually ask for the longest they have, and the longest they have is usually like 175s in that area. Or I think maybe one time I skied on 180s, but I think 175s, 170s there's plenty of ski underneath your foot. I mean, that's, as Jeff knows, the width of the ski helps you float. And, they can be shorter because they're wider. So you're really getting the same flotation under your ski.
Mm.
And much more maneuverability.
Yes, exactly.
All right, and then I don't know if we have time for another poll question, but if we do, let's do the next poll question, which is about how many pairs of skis do you have in your basement?
Oh boy.
Well, that you ski on, so you can't use your husband's or your wife's. It has to be the skis that you ski on. Because, well, in that case, I guess I'm at 4. If I counted Greg, we would be at 15.
I just did a survey in my basement over the weekend here.
Lots of people only have one. Well, golly, I should give you one of mine.
Yeah.
I'll sell you my skate skis. I've decided I can't do that.
All right. Do you want to hop into the next one, or you want to keep going?
Well, I think asking the last question would be good. So the third question asks, what is your favorite snow condition to ski in? Groomed corduroy, powder, spring corn, or ice?
Let's see how many people choose ice. Whew.
I learned to ski on ice. I did. I swear I learned to ski on ice in New Jersey as a Girl Scout. And that's why I can't ski powder. I just dig in too much, and I just don't understand.
Oh,
I can help you out with that.
I need a ski instructor. The groomed corduroy, that's what people like. Very cool. I've never even heard that phrase.
Oh yeah.
So right after when they freshly groomed snow, all the little it just looks like corduroy on the hill.
I've skied that. I've certainly skied that. All right, so I think we're at the end. So why don't you stop sharing your screen, Jeff, so that the people can see you guys.
Oh, I'll have one. I'm just gonna put this
up.
Oh
yeah, one more slide for sure.
I figure you could learn more about us at skishaggies.com. And I'm a young entrepreneur, so I had to put in, if anyone is looking for skis, they can use Husky Bites.
Oh, fun. As a code?
As a code, and save $75.
Oh, well, that's fun. Very good. So I'm just going to read out the URL,
skishaggies.com.
So skishaggys.com.
That's correct.
Yep.
Super.
It is a great website. I did want to mention that. And, I did my Google search before I volunteered. I just wanted to let you know that.
Oh, well, that's good to hear.
Thank you, Iver, and I love the t-shirt you're wearing, by the way. It's fabulous. And your hat, Jeff. All right, so guys, have a field day with the questions, and at 7:00 I will kind of just wrap things up for the recording, but let's stay on for a few more questions because there are 35 out there to be answered. So. And you guys can, click on Q&A and then click choose to answer live if you want to answer it live, and take turns.
All right. Let's see.
And once they've been answered, you can there's a way to kind of make them go out to the field of view.
Okay, well, we'll say for the Shaggies use any recycled materials in the ski, making it more sustainable. That's a great question. As of right now, very few of the materials that go into a ski are recycled. The plastic for the base material, the sidewalls, and some of our tip and tail bumpers has to be here. It is virgin material to make sure that it's not contaminated, because it is historically, and it is a very difficult material to bond. So it's very controlled. I hope that in the future we can figure out how to get the manufacturer to start reforming recycled material. But we are actually working on right now a way to remove a large portion of the plastic waste that goes into the skis, because when we machine the sidewalls that get laminated onto the cores, about 60% of that material is waste. It's not used. So we're actually starting to cast urethane. We've been doing this for about 3 years and trying to get it into our product line for next season, where we actually cast liquid urethane into a negative mold that actually goes ahead and bonds to the core, and then we machine that, but the net shape is already fully there. So there's the amount of material we're losing is we have to over pour by about 5%. So essentially, rather than having plastic surrounding everything, we're just casting urethane, which is more expensive, but we're able to use less of it and have a lot less waste.
That's very good. I think, Jeff, I could take this one from Daryl Junk or Daryl Jock. He's talking about he bought a pair of Head Peak 82s a dozen or so years ago. The graphic included the phrase liquid metal, and he's talking about the only liquid metal he knows of is mercury or gallium, if you happen to have a very hot hand. And I know what that refers to. I think this is refers to probably some sheets that are used for stiffening the skis that are basically bulk metallic glasses. So Liquid Metal is a company formed out of Stanford by Bill Johnson. And they developed several of these compositions that you can make sheet metal out of and have an amorphous structure. So they're very they can be flexible, but they're very strong. So I think that's probably what the liquid metal refers to.
I agree. I think you're right there. Right on.
All righty. We just had one here.
Go ahead. Here's a question from Steven. I don't think we answered this yet. Are your ski edges continuous? He just had a pair of another kind with segmented edges, 1 inch long. They all popped out.
Yeah, that's one of those things. Our ski edges are continuous. They come in a coil that's kilometers long. And there are different companies who have done, like you said, segmented edges. That was one of those things that they tried to make the ski softer by breaking those edges every inch. Like you said, they tend to work their way out. They don't have as much holding power into the ski. So,
and some of them they used to change the spacing between the cracked edge to try to change that overall flex pattern, longitudinal flex.
Mm-hmm.
And yeah, they usually just fell out. Yeah, that's right.
Let's see here. We got Matthew Dina. Hi from California. MTU alumni showing off my Amic 105 skis. Well, thank you for your order. Appreciate the business. How do you design new ski shapes and select materials? Is it primarily by experience, field testing by feel, or do you do FEA analysis or other computer modeling? Thank you for the webinar. So essentially, a lot of this is done with talking to end users and figuring out what characteristics they're looking for in a ski. There's a lot of empirical data, knowing what works, what doesn't work, going along, and coming up with the overall shape. That's a lot by feel and knowledge, coming up with the core profile. There is some analysis that's done to try to maintain a continuous or an even level of stress down the length of the ski. And that's what makes a ski bend very well, so you can make the side cut work. So it's a blend of two, but what it really boils down to is getting that ski on the snow and seeing how it feels, because skiing there's so many factors that go into it. So that's what we do.
Yeah, even within the same materials, I mean, making a tail stiffer or the stiffness pattern, so it's more in the middle of the ski. That's definitely in addition to the materials, then how the materials are used, and for instance, the beam thickness and all of that too.
We actually got a core here, and it's much, I don't know if you can actually see, but
Yeah.
it's much thicker here at the underfoot, and then at the tip of it, it's about 80 thousandths of an inch thick, and then the tail, the tail is about 100 thousandths thick here. So
yeah, absolutely.
that really, there's a lot of work that goes into that thickness profile.
And that's one board. I mean, you're not gluing up the wood.
This is 7.
That's a laminated.
Yeah.
It is laminated. Okay.
Yep. There's
Yes.
ash poplar.
Oh yeah, you mentioned that. That's right. Wow.
And those are all individually flex indexed before they're laminated. So we make the core symmetrical flexing from the inside out. So the block that this is machined out of, it's very important for us to make sure that the cores are going to flex symmetrically from the start, rather than matching materials or measuring the flex at the end and trying to grab a batch of 100 skis and find 2 that are the same. We start at the beginning.
So are
Right,
you measuring flex with a 3-point bend test, or what are you doing? Okay.
Yep, a 3-point bend test.
Nice.
Yeah, here's one of our questioners that is educating us, and I appreciate this. Stephen Conradson says the gutter has been gone for over 35 years. So thank you. I appreciate that. Now I'm smarter. And I think actually this one for you, Jeff, is Kent Barnhart said, would you provide a 45-second description of an elliptical ski versus a traditional ski?
Well, I would say in an elliptical side cut radius is just that. Rather than having a straight single arc, it's elliptical. So it's going to be defined by a major and minor radius. So essentially it is going to, at the end of closer towards the tip and tail of your ski, the arc is going to get tighter. So there's different, like in all of our skis, we actually have, there's 2 to 3 different radii that are blended together. And we actually go the opposite way from that, because your ski generally, as much as you want it to bend perfectly even, generally people drive into the front of your ski and it gets more pressure on it. So it bends a little bit more. So we actually reduce the side cut radius. So we make it a little straighter at the very tip of the ski to account for more bend in it.
Yeah, I would think that elliptical might make it like hooky. I would call, just make a sharp turn for you. Especially,
yep. And there's some companies that do it. Yeah.
Yeah, exactly.
All right. So we have a question. And so speaking to your Michigan Tech experiences, did you have any kind of design experiences that motivated you to kind of go on and tackle some of these huge challenges, like solving the lead-free solder mystery and, designing even better skis? So what did you do at Michigan Tech that kind of motivated you to go on and do those things?
I mean,
go ahead.
I think this question is mostly for Jeff, because I haven't commercialized ski manufacturing, but I've always been interested in material properties and what it takes to get those properties out of a material. So, knowing what's inside the ski is very satisfying to me, and helps me actually learn how to ski that particular board better. So that, I know what the strengths and weaknesses are of the design. Like we were talking about the elliptical side cut. I like the approach that Jeff has taken, where the radius is bigger towards the tip and the tail. And, you know, I paid attention to side cut a lot because, you know, the difference between a slalom ski and a giant slalom ski is pretty big. And it has to do with also the speed at which you want to ski. You know, this comes into it too. Does it feel stable under your feet? You know, that, and so there's a lot of the dampening and the weight distribution and things like that go into the design of a ski. And that's all the kind. I taught skiing for many years also when I was in grad school. So you know, trying to relay what a student should do when they are learning how to ski, to take advantage of the skis that they're using is really important.
Absolutely. I totally agree. I will say, I'll have a shout out here to Professor Josh Locus I had for product